Welcome, traveler of thought. You've arrived at mind-like space, a quiet corner of the universe, where science drifts like stardust, and curiosity moves at the pace of breath. Tonight, we explore the promise and poetry of CRISPR, a tool so small it works between the letters of life, yet so powerful it may heal not only bodies, but entire bloodlines. This is a bedtime story about inheritance and intention, about the ancient shadows in our genes, and the quiet hope of editing them with care. So wherever you're listening from, whether your sky is bright or softly starlit, whether your eyes are beginning to close, or your mind is floating gently above the world, you are welcome here. Let your body rest. Let your thoughts unfold, and allow yourself to drift into the rhythm of wonder. Crescent Moon, before we begin, take a moment to like, subscribe, and tap the little bell, so you never miss another journey through the vastness within. And tell us in the comments, where are you listening from, and what time is it there? Now, breathe in. Breathe out. And let's begin. You lie still, and your body begins to breathe for you. Inhale. Exhale. With every soft rise and fall of your chest, the quiet orchestra inside you plays on, unseen, unspoken, but profoundly alive. Inside each of your trillions of cells, there is a tiny, coiled story, for letters long, endlessly repeated. A, T, C, G. These letters aren't sounds. They aren't words. They are molecules, tiny shapes that pair like puzzle pieces, fitting together in exquisite patterns. And yet, together, they form a language more ancient than speech itself. This is DNA. Deoxyribonucleic acid, though you don't need to remember that. What matters is this: in every single cell of your body, there is a strand of this code, tightly wound, quietly waiting. Not waiting to be found, but waiting to be read, again and again, in loops of quiet devotion. Your body reads this code not with eyes, but with motion. It sends tiny machines, enzymes, skimming along the double helix, the spiral staircase of your genes. They read like old monks copying scripture, faithfully transcribing life's commands: build a muscle, grow a hair, heal a wound, remember a face. And what's most extraordinary is that these instructions aren't just biological. They are deeply personal. The exact shape of your smile, the color of your eyes, the way your skin reacts to sunlight, all of it is scripted in this molecular poetry. Like a composer writing music, your DNA arranges rhythms and repetitions that sing the symphony of you. You inherited half of this script from your mother, half from your father. But even deeper than inheritance is history. Your genes are full of memories, some old, some ancient. Echoes from ancestors you'll never know, written into your cells like fossilized songs. There are genes within you that once helped your ancestors survive in forests, or resist ancient plagues, or digest unfamiliar foods. You carry their victories. And sometimes, their vulnerabilities, too. Now, picture this: your DNA, stretched out, would measure nearly 2 meters in length. And yet it fits inside a nucleus so small it's invisible to the naked eye. It's coiled, folded, and packed with a kind of elegance nature perfected over billions of years. It's not chaos, it's choreography. And somewhere in that choreography, some of the instructions stumble. A single letter swapped, a small paragraph misplaced, a sentence repeated too many times. These are mutations, gentle errors, some harmless, some not. Sometimes they bring variation, making you different in beautiful, harmless ways. But sometimes, they bring pain, diseases inherited through no choice of your own. Your body, though, is not passive. It catches many of these mistakes. It edits and fixes, again and again. There are enzymes, tiny editors, that check the script, looking for misprints, patching where they can. They aren't perfect, but they're dedicated. And it is here, in this silent, sacred space of correction, that the story of CRISPR begins. CRISPR is not something new we built from nothing. It's something we discovered, already humming inside nature. a natural tool used by tiny organisms to defend themselves against viruses, against chaos. Like a pair of tiny scissors, guided by memory. But for now, we stay here with you, in your body, in your breath. Each cell is like a miniature planet, each nucleus a library of life. Inside those libraries, instructions are being whispered, constantly, softly. There is no silence in your biology, only quiet brilliance. You are not just made of matter. You are made of memory. The memories of survival, of adaptation, of chance and change. This is your inheritance, written not in ink, but in base pairs. In every breath, your body follows that ancient script, never rushing, never sleeping. And yet, humanity has begun to ask a new question. What if the script could be changed? Not just read or interpreted, but edited, with purpose, with precision. What if disease could be prevented before it began, by changing a single letter in the code? What if you could guide the body's story, rather than simply listen to it? These are the thoughts that lead us gently, inevitably, to CRISPR. But tonight, you do not need to grasp it all. You are lying still, and that is enough. Just know this, the blueprint of your being is not locked away. It is working, quietly, faithfully, right now. And nature, in its deep intelligence, has given us tools we're only beginning to understand. Outside, the world may be noisy. But here, inside, everything knows what to do. Your heart beats without command. Your lungs fill without permission. Your body, this gentle miracle, continues its quiet work. And as we prepare to step into the next part of our journey, into the bacteria that first held these tiny scissors, we follow the thread of life, unbroken, from your cells to theirs. After all, it was not humans who first learned to edit genes. It was the smallest creatures, in the simplest worlds, who long ago discovered how to defend their own script. And they did so with something quiet, clever, and strangely familiar. You drift deeper now, as if sinking gently into the folds of time. Your body relaxes, your breath slows, and your thoughts begin to ripple, like soft water stirred by wind. Let us journey smaller. Smaller than your skin. Smaller than your cells. Smaller even than the threads of DNA inside your cells. Imagine, now, a world you cannot see. A drop of water, magnified beyond imagination, alive with invisible struggle. Here, bacteria live simple lives. Tiny, single-cell beings, with no nerves, no thoughts, and yet, they survive. For billions of years, they've endured, adapting, shifting, defending themselves from an ancient enemy. That enemy? Viruses. Not the kind that makes you sick, not exactly. These viruses are smaller still. They're called bacteriophages, or simply phages. Like silent invaders, they float through the microscopic world, each one armed with a single purpose, to hijack. They latch onto bacteria, inject their own genetic code, and turn the tiny cell into a factory for more phages. A quiet invasion. And if left unchallenged, it ends the same way every time, the bacteria dies. But nature, as always, has a counterweight. Bacteria, long before humans ever arrived, began to evolve a memory. A defense system. Something extraordinary. Imagine this. A virus attacks a bacterium. But instead of dying, the bacterium survives, and keeps a tiny piece of the virus's DNA. It tucks this fragment away like a photograph, an archive of danger. And then, in the future, if that same virus returns, the bacterium remembers. It builds a tiny guide, a stretch of RNA, like a searchlight, designed to recognize that viral code. And once it finds a match, it calls in a protein called Cas9. Cas9 is precise. It is sharp. It is a pair of molecular scissors. Guided by the memory, Cas9 locates the viral invader's DNA. And snips it. Right at the source. The threat is neutralized. The infection is stopped. Not with chemicals. Not with an army. But with a memory and a cut. This system, the CRISPR Cas9 system, isn't artificial. It isn't synthetic. It's natural. It evolved quietly, over eons, in the humblest organisms on Earth. CRISPR, you see, is not the name of a tool, it's the name of an archive. It stands for clustered regularly interspaced short palindromic repeats, a mouthful that simply means a collection of remembered viral attacks, saved like a diary in the bacterial genome. The Cas9 protein is just one of many that can follow the CRISPR archive. It reads the memory, finds the enemy, and cuts. Clean. Quiet. Precise. Like pruning a branch from a tree before it can rot the roots. And for centuries, this dance, virus, memory, defense, played out silently in the microbial world. No one noticed. No one needed to. Until, one day, humans began to look closer. Not at bacteria to cure disease, but to understand their secrets. In labs filled with quiet machines and glowing screens, scientists began to map this defense system. At first, it made little sense. Why were bacterial genomes filled with repeating sequences, palindromes, mirrored codes, strange fragments? But eventually, like puzzle pieces falling into place, the truth emerged. Bacteria were keeping genetic scrapbooks of their enemies. And they were using that memory to protect themselves, genetically, intelligently, automatically. It was a revelation. Nature had invented its own immune system. One not of cells and antibodies, but of information. And then came the leap. If bacteria could use CRISPR to cut viral DNA, could humans use it to cut DNA of their choosing? Not to defend, but to design? Imagine the moment, a quiet one, really, in a lab like any other. A scientist holds a tiny pipette, mixes a guide RNA with a Cas9 protein, and sends it into a human cell. The guide RNA searches. The Cas9 follows. And then, a snip. A gene is edited. A trait is altered. A future begins. But for tonight, we remain in the soft beginning. We do not leap ahead. We linger here, in this strange and wondrous fact. The most powerful genetic tool ever known came not from invention, but from observation. Bacteria had been doing this for billions of years. Silently. Without fanfare. Nature had already built the scissors. We only borrowed them. And as you sink further into sleep, remember this. The vast, complex machinery that now promises to cure disease, alter inheritance, and shape the destiny of species. All began in a droplet of water. In the smallest of worlds. With the simplest of beings. Guarding their little lives with a clever memory. CRISPR's story, like yours, is made of patience. Of quiet survival. Of trial and error written into the deep code of life. And as we move into the next chapter, you'll discover how those molecular scissors now whisper to our own DNA. Searching. Matching. Preparing to snip. Not in harm, but in hope. There's a rhythm beneath your resting breath. Not just the rise and fall of your chest, but deeper still, in the silent turning of your cells. Within them lies the double helix, twisting, looping, dancing in coils of gentle instruction. Picture it now. A spiraling ladder, endless and elegant. Each step a rung of code. Each rung made of 2 letters, A with T, C with G. Like soft hands clasped in molecular prayer. This is the architecture of life, your life. And though invisible, it is more constant than your pulse, more foundational than your thoughts. It holds the pattern of your skin's tone, the cadence of your heartbeat, the sensitivity of your eyes to morning light. All of it encoded in that silent spiral. But how does CRISPR know where to begin? To understand that, let's slow time down. Imagine a single strand of DNA, uncoiled and gently drifting in a warm current of cytoplasm. It floats like a ribbon, curling with purpose. Now, picture a small guide, like a whispered line of poetry made of RNA. It's short, purposeful, and specific. It's written to match a single phrase, a sequence, in the entire genomic book. This guide RNA is CRISPR's compass. And Cas9, the molecular scissors, is the hand that holds it. Together, they move as a pair, drifting gently through the nucleus, seeking a match. Like a lullaby searching for its final verse. And when they find it, that perfect alignment between guide and genome, it's as if the sequence sighs in recognition. A subtle click. A door opening. Then, a pause. And a snip. The DNA is cut. But don't imagine chaos or violence. This isn't destruction. It's more like a careful seamstress finding a loose thread and clipping it clean. It's surgical. Intentional. Gentle. Once the cut is made, the cell itself responds. It rushes to repair. It doesn't want a broken strand any more than we want a wound. So, it brings its repair enzymes to the site, like tiny healers, patching the broken spiral. And here's where the magic of CRISPR truly unfolds. Because if scientists provide a new template, another piece of DNA, carrying a new message, the cell might use that instead. It might copy from the new strand as it heals. And just like that, a new trait is written into the code. Like slipping a new sentence into an old, beloved book. The story changes, quietly, permanently. This process is called homology-directed repair. But don't worry about the name. All you need to know is this. CRISPR doesn't just cut. It listens. It guides. It edits. Like a translator correcting a sentence for meaning, not just grammar. And what's most profound is that it does all this using the logic already built into your body. Your cells already know how to repair themselves. CRISPR simply gives them a reason to try something new. There's something tender about that, isn't there? We so often think of science as separate from us, cold, mechanical, external. But here, the technology of gene editing is woven directly into your biology. Into the rhythms that have been there since your first cell divided. Into the whispers of your double helix. Now, close your eyes and imagine this sequence. A baby, still forming in the womb. Its cells multiplying, dividing, each one carrying DNA passed from its parents. Each line of code shaping who it will become. And with CRISPR, a scientist adds a guide. Just a sentence. Just a nudge. They fix a gene that would have caused blindness. Or remove a mutation linked to a devastating illness. They do not change the child's soul, only the fault in the script. The baby will never know. But the code will carry the change. Forever. That's the promise, and the mystery, of CRISPR. It doesn't overwrite who we are. It simply gives us a choice to listen more carefully. To the genome's poetry. To its pauses and repetitions. To the places where time has stuttered, and science might offer a softer rhythm. But even as you lie here, warmed by this unfolding, remember. The genome is not a machine, it's a living story. Full of nuance. Full of unknowns. Changing one part may echo across many others. Still, tonight, as you let your breath deepen and your thoughts quiet, hold this truth like a stone beneath your pillow. Inside every cell, there is a story being told. And now, for the first time in history, we've learned how to whisper back. Next, we'll wander into the future that this whisper creates. Where the dream of perfection tugs at human hands. And where choice meets caution, in the editing of life yet to be born. You breathe in, and the world seems to slow. You breathe out, and the future drifts a little closer. There is a dream floating gently across the fabric of time, whispered in labs, murmured in nurseries, pulsing softly beneath the surface of science. The dream of perfection. Not perfect in the impossible, glowing way that fairy tales suggest. But perfect in the way that science sometimes dares to imagine. What if we could remove suffering? What if we could make our children stronger, smarter, immune to pain? What if we could choose? You lie back and drift further into this question, letting it echo gently through your mind. For centuries, parents have passed on traits to their children blindly through the quiet dice roll of inheritance. A father's smile, a mother's blood disorder, a grandfather's long fingers, a grandmother's early memory loss. It all comes wrapped in the invisible gift of DNA, sealed in cells too small to see. But now, with CRISPR, that gift can be opened early, edited, rewrapped, and returned with changes. Imagine this. A parent sits in a genetic counselor's office, holding a page of code that belongs to an embryo. A future child, not yet born, not yet breathing. But already, a story is being written. One mutation, here, increases the risk of a heart defect. Another, there, may lead to early blindness. Elsewhere, a gene linked to lower immune resistance. All editable. Then come the subtler questions. What about intelligence? Height? Eye color? Memory? Musical ability? Should we correct these too? Do we call it medicine or design? And in the quiet between those questions lies a breathless longing. A longing not for perfection in the cosmic sense, but for control, for safety, for a gentler path forward. As you float through this chapter, imagine this dream as a painter's studio. The embryo is the canvas. The genome is the palette. And CRISPR is the brush. Each stroke is subtle. Each change is silent. But together, they shape a child who will never know what was altered, only what was given. You may feel wonder here. That's natural. But you may also feel a flicker of unease. That, too, is natural. Because perfection is a concept soaked in shadows. What one family sees as a gift, another may see as a loss. A quirk removed might have become a strength. A challenge left untouched might have built compassion. Who decides what is desirable? There are whispers already of a future market. Not just for disease prevention, but enhancement. For upgrades. For options. A catalogue of possibilities. Would you like higher math aptitude? Reduced aggression? Enhanced emotional stability? Premium memory retention? It sounds surreal. But the science, slowly, sleepily, moves closer to making it real. And so, you rest in the middle of the dream, half promise, half puzzle. You think of your own body now, resting in the dark. Every imperfection you've learned to carry. Every trait you never got to choose. Would you erase them? Would you unwrite the parts of yourself that taught you how to love, to fight, to hope? We often forget that life grows not only through ease, but through friction. That the most meaningful stories often bloom in the cracks. Still, the temptation is strong. To spare a child from suffering. To offer them a world slightly softer than the one you knew. To edit out pain before it begins. This is the lullaby of CRISPR. Let me protect you before you even know what danger is. And yet, tucked inside that lullaby is a choice so heavy it barely whispers. Because to select one path is to close another. To choose a trait is to choose countless others. CRISPR doesn't give us unlimited imagination, it gives us a scalpel. A way to remove. A way to refine. But not always a way to understand what we're taking away. So where does the dream end? Perhaps not in dystopia. Not in designer babies with glowing skin and engineered genius. But in subtler places. A child who never gets sick, but never cries deeply. A teenager who excels in math but struggles to make friends. A society that slowly, silently, begins to value sameness over surprise. Perfection may not arrive in dramatic forms. It may come quietly, softened by good intentions, polished by data, justified by love. And so we must ask, is a world with fewer flaws always better? Or is it simply more manageable? Tonight, you drift through this tension like a feather in still air. You are not being asked to decide. Only to listen. Only to wonder. CRISPR offers no moral compass. It is a tool. A brilliant one. But in our hands, it becomes a mirror. And perhaps that is the softest truth of all. That in editing our children's genes, we may reveal more about ourselves. What we fear. What we value. What we hope will live on. And as you close your eyes, the dream doesn't fade, it folds itself gently around your mind, like a blanket. It asks no answers tonight. Only this? What if the future child could speak to you? Would they thank you, or ask what might have been? Next, we'll return to where this dream first crossed into waking life. To the moment 2 human embryos were edited. And the world quietly stepped across an invisible line. Your body lies still, but your thoughts begin to float, drifting through the quiet corridors of memory and science. Tonight, you are traveling not just through the body, but through time. And the year is 2018. The world, above the surface, carries on with its usual rhythm. News cycles, quiet dinners, newborn cries in hospital rooms. But beneath that ordinary hum, in a quiet lab in southern China, something unfolds that has never unfolded before. 2 embryos. Not yet babies. Not yet names. Just microscopic clusters of dividing cells, floating gently in nutrient fluid. And yet, within them, a sentence of life has just been rewritten. This is the story of Lulu and Nana, the world's first CRISPR-edited humans. Their real names were never released, their faces never shown. But their existence marked a turning point, not just in science, but in the story of our species. It began with a scientist named He Jiankui. Ambitious, brilliant, and certain that what he was doing would be remembered, not as defiance, but as innovation. He believed he was taking the next step. That he was giving these children a gift. A shield. You breathe in and imagine what he saw. 2 parents. A father living with HIV. A mother without it. A future filled with medical risks, not for the parents, but for the children they hoped to have. So He Jiankui made a decision. To use CRISPR to edit a gene called CCR5, a doorway on the surface of certain cells that HIV uses to enter the body. The goal? To remove that doorway. To make the embryos, Lulu and Nana, resistant to HIV. To give them an immunity they didn't yet need, for a life they hadn't yet lived. He believed he was being careful. The edits were small. The technology was precise. The embryos would be implanted. The babies born. And the world would change. But science, like life, rarely moves in straight lines. The announcement of their birth, made not by scientific consensus, but through a YouTube video, shocked the world. Not because CRISPR had been used, but because it had been used so soon. Without clear oversight. Without full understanding. Without knowing what else might have been altered along the way. You see, the CCR5 gene doesn't just open a door to HIV. It also seems to influence brain development. It may affect memory, cognition, even social behavior. So while the doorway to one disease was closed, other doors, unknown, unmeasured, may have swung open. And no one knew what the long-term effects would be. The scientific community responded with stunned silence. Then with anger. Then with fear. Because what had once been hypothetical, designer babies, edited traits, heritable change, was now real. 2 human beings were born with edited genomes. Not as part of a clinical trial. Not with international consent. But quietly, suddenly, permanently. You lie there, and you wonder. Were Lulu and Nana harmed? Were they protected? Are they thriving now, somewhere in a quiet corner of the world? No one knows for certain. Their identities are protected. Their future, still unwritten. But what we do know is this. A boundary was crossed. Not just by a man with a lab coat and a vision. But by all of us. By the very idea that we could. Until that moment, CRISPR had been a promise. A theory, a possibility, wrapped in ethics and care. But now, it had a heartbeat. 2 of them. You might feel the weight of that as you lie in the dark. Not as a fear, but as a breathless realization. The future doesn't always arrive with fanfare. Sometimes it slips in quietly. Between heartbeats. Between headlines. And now the questions come, not with noise, but with whispers. What changes were passed on to Lulu and Nana's future children? Will the edits ripple through generations, harmlessly or not? Should such changes be inherited at all? Gene editing doesn't pause with the first snip. It continues with every cell that divides, with every life that grows from it. And so, the world responded not with celebration, but with caution. Scientific bodies around the globe condemned the act. Laws were rewritten. Conferences were held. He Jinkoway was sentenced to prison. But the technology remained. The scissors hadn't broken. The guide RNA still waited, like a map with endless destinations. Tonight, as your eyes grow heavier, know this. The story of Lulu and Nana is not about villains or heroes. It is about the delicate line between care and control. Between healing and hubris. Between what is possible and what is wise. We are a species that builds fire and sometimes forgets how to hold it. And yet, from that fire comes light. From those missteps come reflection. The future of gene editing may still bring healing, may still offer hope. But it now moves forward with deeper humility. And you, listening now, are a witness to this turning point. Not through textbooks or trials, but through stillness. Through soft questions that drift like leaves across your resting thoughts. Lulu and Nana are out there, somewhere. Growing. Learning. Living a life whose beginning was shaped by something most of us will never feel. A tiny, invisible snip made before their first breath. And as we leave their story behind, we move toward a gentler place. Back to your own body, where CRISPR is not altering, but mirroring what already exists. Because the truth is, your cells have been editing themselves all along. Silently. Lovingly. Tirelessly. And in the next chapter, you'll listen to that ancient repair system. The one that inspired CRISPR in the first place. Already at work inside you, even now. You are resting now. Still. Quiet. But deep inside your cells, there is a quiet flurry of work. A team of caretakers you will never see. Busy at tasks they've performed since before you were born. Even now, as your body falls into rhythm with sleep. These microscopic artisans are hard at work. Finding cracks, smoothing breaks, sealing little tears in your molecular fabric. They are your body's repair kit, tiny, tireless, precise. It begins with DNA. That winding, whispering helix we visited in earlier chapters. Your code. Your blueprint. But no matter how sacred, DNA is vulnerable. To radiation, to chemicals, to time itself. Each day, you encounter things that can nick, damage, or tangle your DNA. A ray of sunlight. A puff of smoke. Even the simple act of living. Breathing, eating, dividing cells. Creates occasional errors in the code. And yet, you do not fall apart. You do not unravel. Because inside you are tools. Not machines. Not metal. But enzymes, soft, molecular tools built by nature. They move along your DNA like careful weavers through a tapestry. Reading. Checking. Repairing. There are many types of repair. Each suited for a different kind of mistake. Some enzymes fix tiny single-letter changes. Others repair larger breaks, even double-stranded ones. Where the spiral has been split apart. Like a snapped ribbon drifting in cellular wind. One of these repair systems is called non-homologous end joining. A long name for a simple idea. Grab the broken ends and stitch them back together. It isn't perfect. Sometimes a few letters get lost. But it's fast. The biological equivalent of closing a cut before it becomes a wound. Another, more delicate process is called homology-directed repair. This one waits for a matching strand, like a reference page in a book, and copies from it with care. It's slower, more thoughtful, and it's this method that CRISPR often borrows. You see, CRISPR does not force your body to repair DNA. It simply initiates a cut, and then waits. The cell does the rest. It rushes in with its natural instincts to heal, to fix, to restore balance. And if we give it a new piece of DNA as a template, the cell may choose to copy from it, as if reading from a new line in the script. It's not manipulation. It's persuasion. A soft suggestion to a body that already knows how to heal itself. This is the genius of CRISPR. Not that it forces change, but that it guides natural processes in new directions. Like nudging a river to flow toward a field that needs watering. As you lie still now, imagine millions of tiny repair teams moving through you, each one humming along invisible scaffolds of DNA. Each one smoothing phrase, sewing breaks, double-checking the code. They are your guardians, your editors, your quiet, constant caretakers. Even without CRISPR, your body edits its genes every single day. Not to redesign you, but to protect you. To keep your cells aligned with who you are meant to be. In this way, CRISPR is not an outsider. It is an apprentice, learning from a master whose craft is older than time. It has studied your cells' repair tools and learned how to work with them, not against them. So tonight, as you rest, let yourself feel this harmony between human intention and natural design, between tool and instinct, between science and the soul of biology. There is no rush here, no noise, only repair, only rhythm, only breath. And as you drift deeper into sleep, you carry this knowing that even in your most silent hours, you are being cared for, mended gently by forces you'll never need to command. Next, we will step out again into the wide web of the genome, where single edits can ripple through systems, changing more than we might expect, and reminding us that in nature, nothing is ever truly isolated. You are quiet now, breathing slow, your limbs heavy like stone warmed by sun. In this deep calm, we go further into the complexity hidden beneath simplicity. Because in nature, nothing stands alone. And in your body, everything is connected. Your genes do not act like solo performers. They are more like instruments in a symphony. One string vibrating, calling forth a subtle resonance in another. Even the smallest change can shift the entire sound. Tonight, let's imagine your genome as a vast woven tapestry. Each gene a thread, colored, textured, twisted gently through loops of meaning. Some threads lie close, touching. Others stretch long distances before they connect. But all of them, somehow, are part of the same pattern. Now, picture a hand, gentle and curious, reaching to tug one thread. Just a little. Just a correction. And the blanket ripples. Softly at first. Then deeper as the tug travels along neighboring threads. Changing folds. Altering the shape. Sometimes for the better. But sometimes, unpredictably. This is the hidden truth of gene editing. We often aim at one trait, one illness, one mutation. But traits are not single points in the genome. They are networks, emerging from the quiet collaboration of many genes and their environment. Let's say we edit a gene to reduce the risk of Alzheimer's. That sounds like healing. But what if that same gene also affects immune function? Or mood? Or the way neurons speak to each other in early childhood? Or imagine we tweak a gene that influences height. It's not just bones that respond, but hormones, metabolism, even the rhythm of growth itself. It's a quiet domino effect. Not a line of falling blocks, but a breeze through tall grass. Each stalk bending, each one brushing against the next. This is called pleiotropy, when one gene touches many traits. And it is more common than we once believed. You carry genes like this. We all do. A single gene might help regulate your blood pressure, and also influence how you respond to stress. Another might protect your cells from damage, and also shape your skin tone or reaction to sunlight. So when CRISPR enters the cell with its quiet scissors, even the smallest cut must be thoughtful. Even the most careful edit may awaken echoes we didn't expect. And it's not just the genes themselves, but the switches between them. Your DNA is not just letters, but punctuation, commas, pauses, silent emphasis, sections that do not code for proteins, but control when and how and where genes speak. These are called regulatory regions. They are the conductors of the genomic orchestra. And sometimes we do not see them clearly. An edit made too close, even if unintentional, could shift the entire tempo. A gene that once whispered may now shout, or fall silent. You are more than the sum of your genes. You are how they talk to each other, how they express themselves over time, how they respond to warmth, to hunger, to fear, to sleep. And so, in gene editing, precision must be paired with humility. Because when we change one, we may change all. But don't let this fill you with worry. Let it fill you with wonder. Wonder at how deeply interconnected your biology is. How brilliantly your cells negotiate change. How your body, every day, manages a million microbalances. Without a word. Without a pause. CRISPR does not override that balance. It enters gently. But the risk lies in forgetting how complex the balance truly is. Imagine now, in your soft half-sleep, a butterfly landing on a still pond. Its wings brush the surface. Ripples bloom outward. Not loudly, but without end. This is the nature of editing life. Not like sculpting stone, but like touching water. Every change expands. Every ripple travels. Every edit echoes. And yet, in this truth, there is also beauty. Because even as we navigate the unknown, we do so with growing care, with deeper knowledge, with maps drawn from the mistakes of those who came before. And always, always, with reverence. Nature has taken billions of years to build the genome you carry. It did not rush. It experimented. It adapted. It listened. So as we now hold the tools to shape that genome, let us listen too. Let us remember. Every thread is tied to another. Every whisper has a response. Every change we make reveals how much more we still have to learn. And as you drift towards sleep's soft center, you carry this truth gently within you, that even the smallest step toward healing requires the greatest patience. In the next chapter, we step not into the body, but into the soul of science, where decisions aren't made in labs, but in hearts, where ethics blooms in silence, and where each question begins with, should we or not just can we? Breathe in, softly. Let the stillness of this moment wrap around your thoughts. Let your muscles sink into the bed, as if gravity is tucking you in. And now, let us move into a quieter realm. Not of molecules, or enzymes, or genes, but of questions. Questions that don't hum in test tubes, but linger in human hearts. CRISPR, as we've seen, is a remarkable tool. It gives us precision. It gives us potential. It gives us a new kind of language, to speak directly to life itself. But what should we say with that language? And what, if anything, should we leave unsaid? You see, science often moves faster than reflection. We discover before we understand. We can, before we ask, should. And so, as CRISPR enters the world, not as theory, but as action, we find ourselves in a field not of facts, but of ethics. Imagine it now, a gentle crossroads, bathed in twilight. For paths ahead, each inviting, each uncertain. To the left, therapy, using CRISPR to heal disease, to repair broken genes, to ease pain before it begins. This path is familiar, compassionate. It feels right in the hands, like a key made to fit. To the right, enhancement, editing not to heal, but to improve, to sharpen memory, raise IQ, reduce anxiety. This path is paved with desire. But beneath the beauty, there are questions. Who decides what's an improvement? And who gets access? Ahead, a third path, germline editing. Changing embryos. Making edits that will not only affect one life, but generations to come. This is the longest path, one whose end we cannot see. A single snip may echo through centuries. And behind us, restraint. The choice not to walk forward, to hold the tool in hand, but choose not to use it. This is not fear. This is wisdom. This is the recognition that having power is not the same as being ready to use it. As you lie here, resting between breath and thought, you can sense the weight of these paths. None are evil. None are perfect. Each is lined with questions that flicker like fireflies. If we edit embryos, do we also edit freedom? If we enhance traits, do we risk losing diversity? If only the wealthy can afford edits, what happens to the idea of fairness? If mistakes are made, who bears the cost? If we succeed, what do we become? Ethics is not about halting science. It's about accompanying it. Like a soft hand at the elbow, gently asking, where are you headed, and why? And ethics, like CRISPR, lives in details. In how consent is gathered. In whether communities are included. In how we define normal, healthy, or for desirable. It asks us to slow down. To listen to many voices. Scientists, philosophers, parents, children, elders. Because the genome belongs to no one. And to everyone. In some countries, germline editing is banned. In others, it's unregulated. Around the world, debates unfold like quiet storms. In conference rooms, classrooms, living rooms. And yet, in every place, the same hum beneath the words. We are editing life. We must move carefully. So tonight, let your body rest, while your heart walks gently through this field of questions. You don't need to solve them. You only need to feel their shape. Let your breath rise and fall like scales, weighing not just facts, but values. Because ethics, like the genome, isn't a single strand. It's a weave of hope and caution, of care and courage, of responsibility and wonder. And you, just by listening, are part of that weave. You are not a bystander to science. You are its echo, its witness, its conscience. As you drift deeper, let this thought nest softly beside you. The future is not built by the bold alone, but by the thoughtful. In the next chapter, we turn gently outward again, to the wild diversity of life itself, where CRISPR may help not only humans, but forests, oceans, and creatures of every kind. Your body rests in softness. Your thoughts drift like leaves on water. And now, you step into a world not made of cells and surgeries, but wind and water, feathers and fur, bark and bloom. Because CRISPR does not end with us. It moves outward, into the wild. And the wild is listening. Imagine now a dense forest, thick with trees that drink sunlight and whisper with insects. Beneath the soil, roots stretch and spiral, exchanging signals, sharing resources. Above, birds slice the air, mammals rustle through brush, seeds fall like quiet prayers. This is an ecosystem. A network of life so deeply interwoven that even the smallest change can echo for miles. And now, imagine slipping one small change into this web. Let's begin with the mosquito. For centuries, mosquitoes have carried diseases. Malaria, dengue, Zika. Tiny wings, heavy consequences. With CRISPR, scientists have begun to design gene drives. Genetic edits that spread rapidly through a population. Edits that don't just whisper, but shout. One such drive could make mosquitoes sterile. Another might make them unable to carry disease. Released into the wild, these edits would not just affect one mosquito, but the entire species. It sounds like salvation. It could save millions of lives. But what else might it change? Mosquitoes, after all, are food for birds, fish, bats. Remove them, or alter them. And what follows? Nature is not a collection of parts. It is a song, and every species is a note. Pluck one, and you shift the harmony. Now drift further, into oceans, where coral reefs are bleaching. Warming waters stress them. Acidification weakens them. And yet, with CRISPR, we may be able to make them more resilient. Edit their genes so they withstand heat. So they survive. Not to dominate, but to defend. And on land, our crops wait too. Corn, rice, wheat, cassava. We edit them for drought resistance, pest resistance, yield. CRISPR allows farmers to nurture food in ways that once took decades. Without adding foreign genes, just by tweaking their own. Even extinct species whisper at the edge of possibility. Could CRISPR bring back the woolly mammoth? Could it restore traits lost in endangered animals, helping them survive our rapidly changing climate? These ideas shimmer between wonder and warning. Because once we begin to edit nature, we must be prepared to become part of it. We are no longer observers. We are participants in the gene pool. We change it, and it, in turn, may change us. And the questions grow. Who speaks for the wild? Who decides when a species should be edited? Can an ecosystem consent? Can we undo what we've changed? Sometimes, we edit to fix what we broke. We introduce disease-resistant trees because we introduced the disease. We edit fish to adapt to polluted waters because we failed to keep the waters clean. CRISPR may help us heal, but it also reveals where we've harmed. So as you rest here, blanketed in the hum of unseen forests, know that gene editing in nature is not a story of conquest. It must be a story of relationship. To edit the wild is to touch something ancient, something that has never asked to be changed, but may allow it if we learn to listen. CRISPR does not offer easy answers. It offers new tools, new metaphors, new invitations, and maybe the gentlest path forward is not to wield it like a sword, but to carry it like a flute, carefully, respectfully, learning when to play and when to be silent. Because nature, too, has its editors. Wind, fire, mutation, time. We are simply joining a process already in motion. Tonight, let that thought settle like dew on your skin. You are part of nature, and nature is part of you. The forests you edit may shape the air you breathe. The crops you protect may feed the strangers who grow your food. The insects you alter may one day change the birdsong outside your window. CRISPR is not just about control. It is about collaboration. And as you drift deeper, let this question float gently in your chest. If we learn to edit life, can we also learn to care for it more deeply? In the next chapter, we'll return to the human body one last time. To the promise of healing not just individuals, but entire lineages. By rewriting the genetic roots of disease. Close your eyes. Let your breath soften. Now imagine your body not as a single story, but as part of a long and winding river. This river stretches back to your parents, their parents, and farther still, to ancestors who walked beneath unfamiliar stars. Along this river flows more than memory. There are patterns, wounds, and silent threads of inheritance. Some are beautiful. A grandmother's laughter carried in your smile. A grandfather's steadiness beating in your heart. But some are heavy. A blood disorder. A fragile chromosome. A mutation tucked deep in the genome. Passed unknowingly, unwillingly, from one generation to the next. Sickle cell anemia. Cystic fibrosis. Huntington's disease. Muscular dystrophy. Tay-Sachs. Each one a quiet shadow, waiting in the code. Now imagine. You could reach into that river, find the thread, and gently, gently untie the knot. This is what CRISPR dreams of doing. Not just healing one person, but ending the passage of pain itself. Turning inherited suffering into a closed chapter. For many families, genetic disease is not abstract. It is lived. It is the fear at the first ultrasound. The weight behind every blood test. The grief of watching a child's body betray them. CRISPR offers a promise wrapped in science. What if we could stop this here? Let's visit a cell now. From a child born with sickle cell disease. Their red blood cells are misshapen. Not round and soft, but curved like sickles, stiff and brittle. These cells get stuck in blood vessels, causing pain, fatigue, even organ damage. But the mutation that causes this is just one single change in their DNA. Just one letter. One spelling mistake. And in clinical trials, CRISPR has already begun to repair it. Doctors remove blood-forming stem cells from the patient, edit the DNA outside the body, and return them. A corrected script in hand. The body takes over. The cells grow, divide, and slowly, the symptoms fade. This is somatic editing. Changes made in the body that do not pass to the next generation. But for some, the hope lies deeper. To edit germline cells, eggs, sperm, or embryos. To make a permanent change. So a child not only lives free from disease, but cannot pass it on. This is powerful, profound, and deeply delicate. Because the edit doesn't end with that child. It becomes part of the human story. CRISPR, then, becomes not just a tool of treatment, but of prevention, of transformation. But with that transformation, come the familiar questions. Do we understand all the consequences? Are we ready to alter a lineage? What if the edit affects something else, something unexpected? Who decides which diseases are worthy of being erased? And beneath those questions, a softer one. What if suffering taught us something essential? It's not that pain is noble, but that humans have often learned empathy through struggle, adapted through adversity, grown deeper roots when the wind has been strong. Still, this truth remains. No parent wants their child to suffer. And if we can offer healing without harm, shouldn't we try? These are not decisions made easily, and they should never be made alone. They require scientists, yes, but also ethicists, historians, spiritual leaders, and most of all, families. Families who carry both hope and fear in their blood. CRISPR, in this way, becomes a bridge between past and future, between pain and possibility, between inheritance and intention. And you, resting now, are part of that bridge. You carry within you An ancient story. But you also carry choices that your ancestors could never have dreamed. You are not the end of a lineage. You are its turning point. So let this thought cradle you to sleep. Perhaps healing the future is not just about changing genes, but about choosing love over fear. Choosing to listen, to pause, to ask, to edit not for perfection, but for peace. Next, we approach our final chapter. A closing reflection, where the future breathes quietly, and CRISPR becomes not a tool, but a question carried in the palm of your hand.